Let's look at these components of a vector, but in solving dynamics problems, so what we call resolving vectors. Things don't often happen horizontally and vertically. Often they're off at an angle or something. So it is convenient, again, to break it into what's happening horizontally, what's happening vertically. And once we know what's happening in each of those directions, we can always recombine together into one vector and find out exactly what's happening. So just say we were dealing with one dimension. Okay, we've got a plane travelling south, velocity 100 kilometres per hour. It also has a tailwind of 25 kilometres per hour. What's the plane's resultant velocity? So there's our plane going at 100 kilometres an hour, but then the wind blows 25 kilometres per hour. So the overall effect would be the addition of these two things, and it would look like the plane's going at 125 kilometres per hour. But of course, it doesn't have to be going in the same direction. Same question, but now the wind is blowing easterly, or from the east. So there's our plane, but now the wind is blowing that way. Adding the two vectors together, we could work out the length of that new vector. Yeah, it's around about 103. So it would appear that the plane is going at 103 kilometres per hour. So that's the idea. Now, force. In dynamics, force is where we usually start. And it's a vector. Force is a vector. So it has both magnitude and direction. Start off with a very simple example there. We've got three forces there. Newtons is the unit of forces, so that's what the N is standing for there. But they're broken up into component form, and they simply want to know what would be the result of all these forces. That's just adding the vectors together. So if we add them all together, we get 11i minus 3j. A tractor, you like my tractor? Tractor's pulling a barge along a canal with a force of 400 newtons. Okay. We need to find the component of the force in the direction of the motion. So really what we're saying is we're going to project, I've called the vector that's at the angle t for tractor. So we're going to project t onto the bank, so the horizontal one. And we know that's magnitude of t cos theta times the unit vector in the horizontal direction, which is I. So it would be 400 cos 14 in the I direction. We just want the component, so that's why I haven't bothered putting the I there. But 388 newtons in the horizontal direction. The reality is, when I look at ones like that, I just simply look at the diagram of the forces and I say, well, the angle's 14, the side I'm looking for is the adjacent, so I know it's going to be 400 times the cosine of that angle. If the side I was looking for was the opposite, then I know it's going to be sine of that. A particle of mass 5 kilograms is on this plane. Plane's at an angle of 30 degrees. We have friction acting on this one. It's 15 newtons acting up the plane. We have gravity, or the force due to gravity, I should say, which would be 5g. Find the acceleration of the particle. I want to investigate what's happening down the plane, so I'm going to resolve the force due to gravity into perpendicular components. Remember I said, conveniently we choose horizontal and vertical. For this problem, it's more convenient to choose the angles being the bank, the direction of the bank, and at right angles to the bank. So I'm going to break that force of 5g up into the two components. I've just got to work out where 30 degrees would be in that diagram. So a bit of playing around with geometry, and we can work out the one down the bottom is 30 degrees. So I know the component going down the bank, well, that's the opposite side, so it would be 5g times the sine of 30. So I'm just going to resolve the forces down the plane. So the force down the plane is going to be that component, 5g sine 30, minus 15. Now it's negative because it's in the opposite direction. So I'm making positive going down. So we know that the force, remember, is mass times acceleration. We're trying to find acceleration. Our mass here is 5 kilograms, so I've got 5 times the acceleration is equal to, work out the right hand side, 9.5. We can now work out the acceleration is 1.96. Perpendicular to the plane, because now we want to find the reaction force. So if I look at perpendicular, well, the component of gravity now would be 5g cosine, because now I'm talking about the adjacent side. And it's in the opposite direction to the reaction force, the R, so it's negative. But I know the force perpendicular is 0 because this thing is just sliding down the plane. It's not like it's jumping off the plane. So in that direction, there's nothing happening at all. So the acceleration would be 0, or the force would be 0 overall. So from there, I can rearrange that one, and I get that our reaction force, well, I've left it as an exact value, 5 root 3 on 2 times g. So that's the sort of idea. So just a handful of questions. We'll end up looking at this in a lot more detail in extension 2.